Hey guys, in this session we're going to be looking at particular solutions for differential equations. So let's get started. Now before watching this video, I hope you've had a look at the general solution of differential equations, because if you don't know how to do general solutions, then you probably are not going to know how to do this. So there is a video for that earlier in this series, but anyway. So just a quick recap of general solution. If we have dy dx which equals x, then we know that we can write this as dy equals x dx, and then integrating both sides we would get y equals half x squared plus c. The thing is, we put c because we don't know what it is. We don't know what the value for c is, and that's why this is called the general solution. Now this is almost similar, if you actually think of it in graphing terms. This is a family of curves, for example. Let me just show you guys here. So for example, this could be half x squared plus c, but you could also have this, because c could be 1, or c could be 2, or it could be -1, -2, -3. So you've got a whole range of curves. Now I've only drawn a few guys, but I hope you get the idea. But general solution is basically when you have a family of curves and you're not really sure which curve you're looking at. Now in particular solution, you're going to find it so that you can actually find which curve you're going to be looking at. Alright, I'll show you guys how to do this in the next slide. So this is how far we got up to with general solution. Now with particular solution, they need to give you some sort of information to figure out what C is. So what I'll do is, for particular solution, in this case, I'm going to say, hang on a minute, let's just put this out first. So we need a point. So let's just say when x equals 2, y would equal 3. Well, this information should be given to you, and then using this information, you can actually figure out what c is. Because what you need to do is substitute x and y. So since our equation was y equals half x squared plus c, then we can rewrite this as 3 equals half times 2 squared plus c. Now rearranging, or actually not rearranging, just solving first, you get 3 equals 2 plus c, therefore c is equal to 1. So the particular solution that you're looking at is y equals half x squared plus c. Sorry, plus 1. So in terms of the graph itself, how it would look like in the graph, there you go, that little blue line that goes through the point 0, 1, that's actually the particular solution. While all the red parabolas, they're all the general solutions, because you don't know what c is. Alright, so let's have a look at another example and see how we go from there. So in this example, I want to write the equation of the curve satisfying x dy dx equals y, given that the point 1, 3 lies on the curve. Okay, so I've got my differential equation here, which is x dy dx equals y. Now I need to find the general solution first, and then I need to work out what the particular solution is. So rearranging things here, I'd get 1 over y times dy equals 1 over x dx. Now integrating both of this, I'm going to get ln of y equals ln of cx. So you might wonder where that c went. Well, normally you'd have, when you integrate, you'd get plus c. I have talked about this in one of the previous videos, so I would ask you guys to go back and look at this. But anytime you want to do integration of 1 over x, it's just good. You'll still get the same answers, but yeah, this is just another way of writing it, ln of cx. Okay, so from here, I know that I can take away both the ln's away with exponential, which means I'd get y equals cx. Okay, so from this point onwards, I have actually been given a point, so substituting x equals 1 and y equals 3. So my equation was y equals to cx. In other words, 3 equals c times 1, therefore c is equal to 3. which means the particular solution that I'm looking for in this situation is y equals to 3x. So guys, that's basically the idea behind this with particular solutions. Now, like I said with general solutions, the one thing you have to be careful with is that when you actually write up differential equations, especially when you're dealing with ln's, you might actually get a different answer from the answer pages in the back of your textbook. But it's just because there's two different ways of doing this. You can actually, sometimes you might actually have the right answer, but it's just written in a different way. All right. But it's always good to just substitute a couple of points in and see if you get the same answer as the answer in the back of your book. But apart from that, that's all for this session. So thank you for watching.